Hello dear students, welcome to Race Academy Bangalore. In this video I would like to introduce some important NEET chemistry refresher capsule questions for this coming NEET examination. See the question number 1. In this they have given one what we call one equation they given like this. Okay, and this means one hydrocarbon given that was actually treated with magnesium triether, and that is giving A, followed by acid hydrolysis giving B. We have to find the right option among these four. Okay, let us work out on this one. Okay, dear students, let us see whatever they are given. First, the hydrocarbon we will take it down like this. The hydrocarbon is given to us is like this with one bromine is present here. With magnesium you are treating in dry ether. In the presence of dry ether you are treating. So what will happens means whatever these dimethyl groups are there, they don't get disturbed. This bromine with magnesium forms RMGX type of compound, Grignard reagent. So what is that Grignard reagent is going to be formed is MgBr like this. So this we can call it as A. And further what they are telling is this one is treated with water in the presence of acid. That means acid hydrolysis is done. In this negative part of this H2O will go along with MgBr. Positive part will come here in place of MgBr. Then what will be, that is, this is hydrogen. This remaining two are CH3 groups. Already given, they are given from the beginning. This is CH3, this is CH3. This is also CH3, CH3. Then the byproduct will be MgOHBr and the final product will be hydrocarbon. So this is CH3, CH3, this is hydrogen. So no need to mention. Class, what is the byproduct is MgOHBr. So MgOHBr is the byproduct in this one. So we have already observed that this is nothing but 2,3 dimethyl cyclo 1,2 dimethyl cyclohexane. It is 1,2 dimethyl cyclohexane. This is A, this is A, this is B. So A is this one, B is this one for this question. See dear student, in this question we have matched the following type: column 1, column 2, or list 1, list 2. If you observe list 1 and list 2, and list 1 should be matched with list 2. In this list 1 we have some organic chemical equations. In list 2 we have some names of the chemical reactions. So to know all these things we should have a discussion on this. We will discuss now. Yeah, let us observe this one. First one, if you carefully observe A, chlorobenzene is treated with that CH3Cl in the presence of sodium metal and sodium metal. Sodium metal will takes away the halogens and forming the methyl benzene called toluene. Actually they have given this toluene is nothing but alkyl benzene. To prepare this type of alkyl and aryl hydrocarbons, okay, we need to discuss about one named reaction. That named reaction is called as Wurtz-Fittig reaction. That named reaction we will call it as Wurtz-Fittig reaction. This is nothing but Wurtz-Fittig reaction. Actually the Wurtz-Fittig reaction in that list in the question they are given in the second Roman. They have given this is second one. Okay, in the list 2 it is there. Coming to the second equation, in the list 1 we have chlorobenzene treated with sodium metal, and sodium takes away both the chlorines forming NaCl and giving the main product as biphenyl or diphenyl we can call. These are the reactions which are called named reaction, comes under fatigue reaction. This is nothing but fatigue reaction. So fatigue reaction is giving this type of diphenyls with the chlorobenzene, that is actually present in the list 2. We have first one, first Roman, it is there. Okay, let us move on to the third equation. That is benzene diazonin chloride given in the presence of cuprous chloride. Chlorobenzene is formed with the liberation of nitrogen gas, they have shown. It means it is one of the named reaction of chlorobenzene preparation for benzene diazonin chloride, that is nothing but Sandmeyer reaction. What is the reaction is called? That reaction is known as Sandmeyer's reaction. Actually, Sandmeyer reaction in this list, you can see carefully in this list, they have provided that fourth Roman as the number, Roman 4 they are given Sandmeyer reaction in the list 2. Coming to the list 1, ethyl chloride with sodium iodide in the giving ethyl iodide plus NaCl. It is a kind of halogen exchange method, usually takes place in the presence of acetone, which is nothing but Finkelstein reaction. This named reaction is called as Finkelstein's reaction. In this Finkelstein reaction, they are given that Finkelstein reaction in Roman number 3 in the list 2. That's why A is matches with 2 and B matches with 1, C matches with 4 and D matches with 3. These are the correct matching for that list 1 to list 2. After looking into the correct matching of this discussion, second option is the right option for this question. Okay, let's move to the next question. So see the question carefully. An alkene is obtained by dehydration of an alcohol. Dehydration of an alcohol. That is why Exxon ozonolysis gives 2 molecules of ethanol for every molecule of alkene. That means X is something alkane, Y is alcohol. We need to find what is the X and Y. Okay, carefully observe this question. An alkene X is obtained by dehydration of an alcohol. Y, Exxon ozonolysis gives 2 molecules of ethanol for every molecule of alkane. So what are X and Y? That we will check it. Okay. See dear student, if you just carefully understand the question, they are telling X on dehydration give alcohol Y. So X is alkene, but X is said to be upon ozonolysis. They are telling one more point. Upon ozonolysis, it is giving 2 molecules of ethanol. 2 molecules of ethanol. So what do you mean by ethanol? Yes, let us see. Ethanol is nothing but aldehyde, acetaldehyde. So acetaldehyde is what? Acetaldehyde is CH3 CHO. Like this we can write. How many molecules? 2 molecules. If we write 2 molecules like this as per the ozonolysis, then if these 2 oxygens actually came from ozone, yes, then we will do one thing, that if you omit these 2 and combine these 2 carbons, what we will get is yes, CH3 CH double bond CH single bond CH3. What is this one? This is exactly what they are asking is X, nothing but 2 butene. 2 butene. And one more time, if you observe carefully, the first statement is giving that alkene upon dehydration gives alcohol. That means dehydration of alcohol gives X, they are telling. So if you take an alcohol like this, on the second carbon, we have an OH group. That means OH functional group. And in the remaining one of the hydrogen also, if you show like this, definitely upon dehydration, the phenomena is called dehydration. That dehydration definitely gives this alkene nothing but again X, that is CH3 CH double bond CH CH3. This is again X. That means Y is an alcohol, that is nothing but 2 butanol. We can call it as 2 butanol upon dehydration is given 2-butene X, that X is said to be ozonolysis gives 2 molecules of ethanol, is exactly matches with this idea. That means what is X? Finally, X is called 2-butene and Y is called 2-butanol. 2-butanol. So dear students, second option is the right option, that is X is 2-butane, Y is 2-butanol is the right option. Let's move to the next question. What is the next question is distillation under reducer pressure is generally used to purify those liquids which. So actually distillation under reducer pressure is a purification technique of organic compounds which will have high boiling points and which decompose below their boiling points. That is the actual statement in distillation and reducer pressure of purification of organic compounds. So in this we have third option is the right option for this question. Yes, let us move on to next question. They are given some statements like this. You observe here, given below the two statements we have. One is labeled as assertion A, and that is and another one is labeled as reason R. Assertion, if you see, experimental reaction of CH3Cl with aniline and anhydrous AlCl3 does not give orthopara methyl aniline. Yeah, it is very clear that orthopara methyl aniline is not coming when the reaction with the methyl chloride in the presence of AlCl3 aniline. Okay, aniline and methyl chloride. Reasons are saying that yes, if you say the reason, the NH2 group of aniline becomes deactivating because of salt formation. Anhydrous AlCl3 yields meta-methyl aniline as the product. Actually, reaction is not coming with A, so how come we say it is meta-methyl aniline? So A is actually correct, but B is false in this assertion reason. That is C option is the right option for this question. Okay, let us move on to the next question. What is the next question is aniline can be converted into benzyl amine by which of the following processes in sequence? Okay, so benzene aniline to benzyl amine. If you observe, aniline can be converted into a compound. That compound we'll call it as benzene diazonium chloride, and followed by that Sandmeyer's reaction followed by hydrogenation, we can have a possibility. Let us check it. Yes, dear student, once you observe how aniline can be converted into benzene diazonium chloride in the first step, aniline is primary amine which will be converted into that benzene diazonium chloride. When we treat that one with sodium nitrite and HCl at 0 degrees Celsius. HCl at 0 degrees Celsius. So in this first sequence we can understand that benzene diazonium chloride can be formed. Second sequence, once you observe here, second sequence in this cuprous cyanide, if you take in the presence of HCN, okay, in the presence of HCN, then what will going to take place is this N2Cl will be completely replaced by Cn, will get cyanobenzene. That means benzene ring is linked with Cn is a Sandmeyer reaction is going to come, which is further undergoing hydrogenation. Hydrogenation in the presence of nickel metal, if you do, this cyanide will be converted into again aniline. That aniline compound, amine compound, primary amine, that is CH2 NH2. So carbon nitrogen triple bond will become this benzyl compound, that sp3 carbon. This is sp2 sp carbon will become sp3 carbon upon hydrogenation. That means what is the sequence is first dihydrogenation, next Sandmeyer's cyano compound, next hydrogenation means reduction process that is going to give aniline into benzyl amine. So what is this compound name? Starting compound name what we have taken is aniline. The final product we obtained is called as benzyl amine. Final product we got is benzyl amine. So for this question, yes, first option is the right option. That means first we will treat that one with nitrous acid and HCl. Next we will treat with CuCN, and finally with the nickel metal hydrogenation. First option is the right option for this question. Next, question number 7. See the question number 7. Salicylic acid on heating with a soda lime forms. What will be formed when salicylic acid is treated with soda lime? Let us see. Soda lime is actually a decarboxylating agent. Only carboxylic acid group will be converted into, will be removed only on the benzene ring. So it indicates phenol is the answer. Let us see how the equation is there. See, dear student, this is orthohydroxybenzoic acid. We can call it as salicylic acid. It has carboxylic acid group is there. This is going to be completely affected when we have taken sodium hydroxide along with the CaO heating, that is soda lime. Then what will be formed is nothing but the OH will remains on the benzene ring and COH will be completely removed. Then that is called as phenol. The compound formed is called as phenol. So phenol is the right answer. When salicylic acid is heated with soda lime, we will get phenol. So in this question, phenol is the right option for this question. That is salicylic acid on heating with soda lime forms phenol. Next question, we will see the reagent from the following which converts benzoic acid to benzaldehyde in one step. See the question carefully. Carboxylic acid converts into aldehyde. Actually, these all should happen with the presence of mild oxidizing, mild reducing agents. All options we have, all reducing agents are there. Lithium aluminum hydroxide and sodium borohydride and manganese oxide KMnO4. Anyway, KMnO4 is not going to be used here in this because carboxylic acid cannot be further converted into aldehyde with KMnO4. And lithium aluminum hydride is converting that carboxylic acid into alcohol, and sodium borohydride also similar fashion. But when it comes to MnO, manganese oxide MnO, that is actually the mild oxidizing agent, converts the mild reducing agent, converts the carboxylic acid into aldehyde. So answer is MnO. What is the answer for this question is manganese oxide. Next question. See the question carefully. In this question, what we understand is nothing but there is a ether given. That ether is treated with cold HI and giving B, hot H, excess of HI giving A. As per the Williamson synthesis and all, we know that whenever the alkyl group, one alkyl group is said to be the tertiary alkyl group, it forms iodide. That means tertiary alkyl group with cold iodide HI forms iodide. A is actually B is actually mixer and A is also a mixer. But what is A? A is a mixture of tertiary butyl iodide and methyl iodide. When you take excess of HI in hot HI, then that whatever B is there, B will be formed as tertiary butyl iodide and alcohol. So when alcohol and iodide will be formed means when we have the cold hydrogen iodide, dilute HI. When we have hot HI, excess of HI is there, then a mixture of the iodides will be formed in the reaction. That we will check it. See, dear student, I have presented the equation. In this equation, we have a tertiary butyl group is there, one methyl group is there. With the cold HI, if you treat, then you will get an alcohol and tertiary butyl iodide. Because this tertiary butyl group is there, the tertiary butyl group is going to be forming tertiary halide. So in both the cases, tertiary halide is the answer. Whereas the cold condition alcohol is the answer. Hot condition we have iodide is the answer, means dehydration also takes place. That's what the difference between this one. So A is a mixture of iodides and B is one tertiary iodide and alcohol. That is the answer for this question. So the answer for the question is second option. Next question. Carboxylic acids are more acidic than phenol and alcohols. What is the reason? So carefully observe. Yes, very simple reason. When a carboxylic acids are taken, they will give H plus ions. Upon ionization, they will be actually subjected to resonance stabilization. Whereas phenol, the conjugate base of phenol is not resonance stabilized. So resonance stabilization of conjugate base of carboxylic acids is making them more acidic than phenol and alcohol. So D option is the right option for this one. Resonance stabilization of their conjugate base. Yeah. Next question, if you observe here in this one, when a both 2 ion is treated with sodium metal in liquid ammonia, what is going to take place? Actually, it is comes under one kind of the reaction, reduction reaction, Birch reduction reaction, where trans 2 butane is going to be formed in this one. When they have given any palladium, Linder's catalyst and all, then it is cis 2 butane is the answer for this question. What is the question here? Carefully observe. In this question, they are given a triple bond compound. The triple compound is 2-butane that will be converted into trans 2-butane, which is subjected to one kind of the reduction in the presence of sodium metal in liquid ammonia. So carefully observe. This is the equation for that 2-butane treated with sodium metal in liquid ammonia. This is we have taken 2-butane and that will be converted in trans 2-butane in this reduction reaction. Okay. This is also called as Birch reduction. If they are given here Linder's catalyst means palladium barium sulfate supported by quinoline solution, in quinoline solution, then your answer will be cis 2-butane is your answer. See the next question. See this question. Which of the following these compounds represents the major monochlorination isomer formed in the following reaction? So we see there are 4 options are there. In this, on the arrow mark we have that chlorine is there in the presence of energies also which they have provided. On seeing this one, what you can understand here is nothing but one point is very clear, that whenever they give like this, the monochlorination is possible in what way, we will check it once in equation part. So if you observe that one carefully, we have one option is there. In the second option, we have that carbon. The carbon is nothing but tertiary butyl free radical. Tertiary radical is there, and tertiary butyl free radical definitely stable. So second one is going to be formed as the major product in this reaction. Okay, second option is the right option. Let us move on to the next question. The order of stability of the following carbon ions. Order of stability of the following carbon ions. If you observe carefully, order of stability, how you can understand this one is nothing but whenever you have the sp2 carbons are there, the sp2 carbons with negative charge are there, they are actually stable. So that will be understood from the structures given to us. We will take the structures and we will discuss. See dear student, these are the 4 actually they are given. In this one, first 2 we don't have any kind of closure structure. Second, third one and fourth one they are given. In third one and fourth one, what we understand is there is an internal double bonds are there. So there is a possibility of conjugation. That means resonance stabilization is possible in 3 and 4. Whereas double bonds are more, means in third one this case is very easy. So third one is more stable than fourth one. In between third and fourth, we have to first finalize the thing. Next, if you move to the first one and second one, obviously the primary carbon ion is stable, and then secondary. So automatically what will come after fourth one? First one will come, last second one will going to come. So why we are not considering these 2 here as second? These are also secondary, but they are undergoing resonance stabilization, whereas here no such type of resonance stabilization. So this is the correct order of the stability of carbon ions. This is order of stability of carbon ions which they have asked. Okay. So, dear students, this is the session we have discussed. This is Race Academy NEET Chemistry refresher course from our Race Academy by YRK'S. So, if you want such type of important refresher course videos and all, please subscribe my channel and share my channel, and to all your friends those are writing the NEET examination or those interested to join in our NEET videos and all, let them allow. Thank you very much.